Let's start with the numericals. First numerical says a solid weighs 72 gram force in air and 63 gram force in water. Find the relative density of solid. So, just use the formulas which I had given you before, substitute the values and find the answer. So, you should start before me. So, I am just waiting for few seconds before I proceed so that you solve it before me. I hope you have solved and just cross check now. Relative density will be equal to weight in air, or let us use the symbols which we had done instead of writing this. So, weight in air W1 upon weight in air minus weight in water. So, what do you have? You have 72 upon 72 minus 63. Now, what is 72? As it is, we will write. What about 72 minus 63? 9, and this will give you 8. You will not have any unit because it is relative density and it was the ratio between two quantities. So, the relative density of the solid is coming out to be 8. Okay children, the next question says the following observations were taken while experimentally determining the relative density of cork. The weight of sinker in water is given to be 32 gram force, weight of sinker in water and cork in air is given to be 34 gram force. Weight of the sinker and the cork both in water is given to be 24 gram force. Using this, you have to find the relative density of cork and also you have to find its density in SI unit. Now, using the formulas that you have already done, just calculate this and then we will check the solution done by you. For finding the relative density, I hope you must have done. So, now finding the relative density, what you need first of all is the weight of cork in air, right. Now, see this data given to you. To find the weight of the cork in air, you can see you have weight of sinker in water, you have weight of sinker in water and cork in air. If you subtract these two readings, then don't you know that the feel that the sinker in water will get eliminated. So, you will have only cork in air. So, you will have 34 minus 32 2GF. This is the weight of cork in air. Next, what you need is weight of cork in water. Now, over here you have weight of sinker and cork both in water as 24 GF. Here you have weight of sinker in water. If I subtract these two, then basically I will get the weight of cork in water. So, this will be 24 minus 32 equal to minus 8 GF. Probably the minus sign over here will surprise you, but remember children, cork didn't go inside the water on its own. It had to be forced inside because there is a large amount of upthrust acting on it. This negative sign only indicates the presence of upthrust. Now, we come to find relative density of cork. So, relative density of cork will be weight in air upon weight in air minus weight in water. So, weight in air is how much? 2. Again weight in air 2, this will be minus and here I get as minus. So, you have 2 and this 2 minus minus will make it plus. So, you will have 2 plus 8. This gives me 2 upon 10. 2 upon 10 means I get it as 0.2. So, the relative density of the cork is coming out to be 0.2. Again, You will not write any unit with it. But now your second part of the question was asking you to find the density in SI unit. When you want to find density in SI unit, what do you need to do? You need to multiply the relative density with 10 to the power of 3 and then write kilogram per meter cube. Density of cork in SI unit, you will have it as 0.2 and you need to multiply it with 10 to the power of 3 and you will write the unit kilogram per meter cube. So, this becomes 200 kilogram per meter cube. So, this is the density of the cork in SI unit. So, now children, the third question that we have is a stone weighs 144 gram force in air and 88 gram force in water. How much will it weigh in kerosene oil? The relative density 0.8. Now, see, this is a question in which you just do not have to find, you do not have to find the relative density. The relative density is given to you and you need to find how much will it weigh in kerosene oil. So, just think and then start attempting to do this question. We should remember relative density of liquid is equal to loss in weight, in this case it is kerosene. So, I am directly writing kerosene, loss in weight in kerosene upon loss in weight in water, right. So, the relative density is given to be 0.8, let us write 0.8 over here. So, it will be 0.8. Then how do you find loss in weight in kerosene? You know it will be weight in air minus weight in kerosene, right, and here it will be weight in air minus weight in water. That means 0.8 is equal to, what is the weight in air given to be? 144. So, this will be 144 minus weight in kerosene, that is what you needed. So, let us me write over here as W. Next you have weight in air 144 minus what is weight in water? Weight in water is 88. So, this is the expression that you are getting, and when you solve this you will get the weight in kerosene. So, now you have 0.8 will be equal to 144 minus W upon 56, and then you cross multiply, you will have 144 minus W is equal to 0.8 into 56. When you multiply 0.8 into 56, you will get 44.8. Now, this W can go on the other side. So, you will have W equal to 144 minus 44.8, which is going to give you 91.2 gram force. So, this is what we are getting as the weight of the solid in kerosene oil. Finally, children, the fourth question that we have, solid object weighs 2.4 Newton in air, its relative density is 7.8. How much the given object weigh if immersed in water and then liquid of relative density 1.2. So, again start doing the numerical before I proceed to tell you the answer. Now, children, we know relative density will be equal to weight in air upon weight in air minus weight in water. You have relative density given to be 7.8 and weight in air is 2.4. So, this will be 2.4 minus W, where I have assumed that the weight in water is W. Now, you need to solve this equation. So, I suggest that, or let us do it 7.8 into 2.4 minus W will be equal to 2.4. So, 7.8 into 2.4 is 18.72 minus 7.8 W. This will be equal to 2.4. Now, you know you have to take W on the other side. So, it will become 18.72 minus 2.4 will give you equal to 7.8 W. So, this is giving you 16.32 equal to 7.8 W, or W will be equal to 16.32 upon 7.8. This is giving you 2.09. So, the weight of the solid immersed in water is coming out to be 2.09 Newton. Now, children, let us come to the second part of this question, that is finding its weight when immersed in the liquid. Relative density is given to be 1.2. So, that means I have relative density of liquid is equal to weight in air minus weight in liquid upon weight in air minus weight in water. So, the relative density is already given to us as 1.2. This will be equal to weight in air is 2.4 minus you need to find the weight in liquid. So, we can keep it as W, and then weight in air again is 2.4, and the weight in air we had calculated to be 2.09. Now, this will give me 1.2 equal to 2.4 minus W upon 0.31. Fine. Now, 1.2 into 0.31 is equal to 2.4 minus W. This is giving me 0.372 is equal to 2.4 minus W. Finally, W will be equal to 2.4 minus 0.372. This will give me 2.028 Newton. So, that means the object will weigh 2.028 Newton in the liquid. So, children, with this we will end up our today's class, and I am posting numericals which of course are from your book. There are around about 6 numericals, and you need to do them and mail them to your respective subject teachers.